Well, here we have exam 2 and problem 3. A UHART student is experimenting with collisions and rolls this ball A that has mass A at block B with a velocity of VA. Right, and there's a coefficient of restitution is E, and a kinetic a coefficient of friction is mu K. Determine the time it takes for block B to come to rest after the collision. Right, so let's move me a little bit so I can get to this right here. So this is the scenario that we have that's coming. And for the values that I used for mine, I said that the mass of A was 2 kilograms. Mass of B was 3 kilograms. I said coefficient of restitution is 0.8. The friction is 0.3. And my initial velocity of VA was, we'll call it VA1 here, 3.5 meters per second. So drawing out the before impulse and then after, we have this taking place, they collide, and then we have this after. So right here is before is MAVA1, kaboom, and then they're going to be equal to MAVA2 plus MBVB2. So, if we wrote out our fundamental equation here, this is what we're doing. We're going to remember. And I didn't mean to put that equals in there. It's supposed to be part of the diagram. I'm going to assume that's positive right there, right? That's part of the assumption there. Summation of momentum here. All right, so easy enough. MAVA1 is equal to MAVA2 plus MBVB2, or 2 times 3.5 is equal to 2VA2 plus 3 times VB2. And that's going to be our equation 1. Maybe we'll even solve what that is. What's should be 7, right? Anyway, so we need another equation. So we go to the coefficient of restitution here. And we say E is going to be V. I'll say B2 minus VA2 divided by VA1 minus VB1, which we know to be equal to 0. And that's equal to 0.8, and this is 3.5. So we have 8.8 times 3.5, or 2.8. It's going to be equal to the difference between, or the relative velocity, we would say, between there. So there's equation 2. So we really don't care about what happens to VA2, so let's solve for that. VA2 is going to be equal to VB2 minus 2.8. Did I get that right? Because he's going to jump over here and he's going to flip over there. Yep, okay. So put him back into this one up here. So what did I say? This is going to be 7 is going to be equal to 2 times VB2. All right, and then 2 minus 2 times 2.8 right there, right? Because I just stuck that 2 and I put both of those in there, plus 3 times VB2. and we get VB2 is going to be equal to, so that's going to be 2 times 2.8, and you're going to add that to the 7. All right, but now we're going to add, and then we're going to divide it by 5. So we get 2.52. How did I do? 2.520, yeah, meters per second. Great. And if you were to care about A2, we would just say, well, that's going to be minus 2.8 from there, or negative 0.2800 meters per second. But so it's going to go back. It's going to bounce backwards, right? So that's what we learned from there. But let's go ahead and figure out this next part. Now, what I had intended people to do, but I've seen a lot of people do a couple other things, was use impulse and momentum. And I should have said to use impulse and momentum everywhere. But let's say that we do our FBD and IBD. And we're going to have weight and a normal, and there is a friction right there, our friction force, and I guess this should be on B, right? And there's also going to be MB acceleration of B. Now, I'm just making this one because I want to make sure that I'm a good professor here and showing you the right way to do things. You know, we see that the sum of the forces in the y direction equals mass times acceleration in the y direction, but it's 0 in this case. So FNB is equal to the weight of B, which is the mass times gravity, which is 3 times 9.81, which is equal to 3 9.81 times, and we end up with 3 9.81 times should be 29.43. And then we get what the friction of B is going to be, just mu FNB. And what did I say? 0.3 times our 29.43. So 0.3 times that, and we have 9.829 newtons. Now, what a lot of people do is they would have found out what this acceleration is, and there's nothing to stop you. Okay, and the friction constant, so the acceleration is constant, so it's a constant acceleration thing, and then they would figure out what the time is going to be after they found that. Well, what I intend you to do was to do another before impulse and after. Right? So that, like, what we have here is we have MB VB2, and now we have an impulse that's happening right here of the friction delta T. So we can write that out, and we can say this is positive right here. And it's going to be, what did I say, this 3 kilograms times our 2.520 minus, because it's a negative direction here, 9.829 delta T equal to 0. So I get a delta T, I guess I'll put the numbers in 9.829. I'm a little leery about, yeah, I just wrote this wrong. I don't know why I wrote that wrong. I'm a little dyslexic. Feeling a little dyslexic. Yeah. I put that in the, so I put it in right, and yeah, there it is, right there in the thing. 3 and 2.52 times, yeah, I get 0.8563 seconds. And I try to change numbers up a little bit in here so that people would get like something maybe a little bit larger than this. I think everybody had. No, a couple people had something that was like along those lines right there. But also note that you could have found from the summation of forces in the x direction, found what the acceleration, deceleration is going to be, and then use that along with this velocity right there to figure out how much time. Nothing to stopping you from doing it. It's totally valid thing. So there you go. There is exam 2 problem 3.